Okay, guys, so we need to talk about section 9.2 a little bit. So here's 9.2 a little bit. 9.2 in your book is called multiplication and division with, and then they write rational expressions, but I'd like to be a little more honest with what this thing is. These are scary fractions, right? Fractions. Okay? Yes, they're scary, but they're still just fractions. So the rules that we know for fractions still work. Okay? So I'm going to give you an example of a fraction and then an example of a scary fraction for both multiplication and division, and then we're just going to practice a bit. Cool? Alright, so an example with multiplication, let's see. We might have reduce to lowest terms. And then there's that bit about assuming the domain blah, 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 right? Assume the domain is restricted to things that don't make you divide by 0, right? So here's our first example with fractions. If we had 3/7 times 21/9, how would you guys do this?
You cross multiply or cross divide or whatever.
Yeah, so don't do this cross cancel thing. So the reason I don't want you to do cross canceling, which is the name of the technique that lots of you know, is that it doesn't work so well with rational expressions because I don't see things quite the same way. Like here I see 7 goes into 21 3 times, right? So I whack the 7, I whack the 21, I left with 3. You guys all with me on that? That's the kind of cross cancel technique. It works, but it's a lot harder to see, for me to see things like, okay, x plus 2 goes into x squared minus 4, x minus 2 times, right? My brain doesn't think that way, so I can't do those quite so fast. So what I want you to do is the kind of dumb way of doing fractions, which is you just write out the prime factors. So you go, all right, I've got a 3 on the top and a 7 on the bottom, and I'm multiplying that by, what's 21?
3 times 7.
21's 3 times 7, and that's over 9, which is 3 times 3. And then I'm saying, okay, so now when I'm multiplying fractions, I multiply all the stuff in the tops together and multiply all the stuffs in the bottom together, right? So I get 7 times 3 times 3 in the top. And in the bottom, what do I get? 7 times 3 times 3. So there's a onesie, there's a onesie, and there's a onesie, right? Okay, so what am I left with?
1.
Oh, good. How many of you wanted to say 0?
Why would we say 0?
Because everything canceled. It all went away.
Oh, no, it all equals 1.
Okay, good. None of you are apparently wanting to make this mistake, or at least none of you are willing to admit it. But there is occasionally the, like, oh, look, everything canceled. Now there's nothing left. Right? Okay, don't do that. There's 1 left, because you're multiplying 1 by 1 by 1. Still 1. Cool? All right. How about with rational expressions / scary fractions? So scary fractions, we do the same thing. So here we've got, say, x squared minus 4 over 3 times x plus 2 over x minus 2. Okay, now this is the thing I said really fast earlier about cross-canceling. You guys see that you can cancel an x minus 2 into this guy and get an x plus 2 out? Maybe, yeah. I would advise against doing that, but you can.
That is so easy.
It works unless you don't see it, and then it's really hard, right? Cool. So I would advise we do the exact same thing. We blast this into factors, and then we just group them. So let's see. On the top, what are the factors of that business?
X plus 2, X minus 2.
Okay, so there's an x plus 2, there's an x minus 2, there's an x plus 2, and then this is all over. Good. Make sure you're getting both pieces, right? Don't lose track of one of the bottoms. All right, now, is there a onesie there? Yeah. That guy's a onesie, right? So I cancel those. And what am I left with here? I'm left with the quantity x plus 2 squared over 3. Is that reduced to simplest terms?
Unless you want us to multiply the top out.
Okay, so just read my brain for a second. Do I want you to multiply the top out?
No.
Probably not. No. So it depends on what you want to emphasize. Like here I'm emphasizing that this function, right, has 2 zeros at x equals -2. You guys see that? If I multiply this junk out, right, then I'm going to emphasize the fact that it's a parabola. You guys see that? So it's a question of what you want to emphasize. I would prefer if you left them factored just because they're easier to grade that way. And because, as a rule, I'm more likely to make a mistake foiling if I actually do it, right? You guys see that? If I don't foil, I can't make a foiling mistake.
Make a mistake.
So I would leave them like this so that you avoid foiling mistakes. Cool? That way the only mistakes you can make are factoring, and those are, yeah, those are kind of the nature of the beast. You're going to make those anyway. Cool? You want to see the dividing one? I promise it's basically the same thing. Yeah, there's not much there. So, all right, let's do the baby dividing one. And I'm really not a huge fan of using this symbol to do math at all anyway. So how about this guy? So let's see. What'd you do? Okay, so we left the front half and then we flipped this thing over and multiplied, right? So all I've got to do is remember the divide by symbol means flip the second thing over and multiply. So one mnemonic for this that I've heard students use is this kind of silly thing about there's dots, which mean you should multiply, and there's this bar that you should flip everything over. I don't care if you use this, but some of you may find that cute enough to remember. Or just do it. Fine with either way. So how do I do this then?
3 times 7 over 2 times 3 times 2.
Okay, we do the exact same thing we were doing just a second ago, right? So we do, all right, this is 3 times 7 over 2 times 2 times 3. There's a onesie. I get 7 over 2 squared. You leave it like this? So I just told you it was okay to leave scary fractions kind of messy like that, right? I would prefer if you evaluated numbers like this, but you can leave the scary fractions with their powers on. Cool?
Would you mark us down if we left it like that?
No, I'm not going to mark you down if you leave it like this. Unless it's really simple, like 0 or 1. Okay? If you want to leave 2 squared, I'm okay with that. If you want to leave 47 to the third, I'm really okay with that. Cool? All right. How about the other one? Where'd my paper go? There it is. All right, let's try a scary one. So we've got, say, 4x squared minus 1 over 18xy divided by 6x minus 3 over 16x squared plus 8x. Okay, can I do this? Yeah. Okay, what do? First things first?
Flip the second half.
Flip and switch.
Okay, so I've got 4x squared minus 1 over 18xy. And now I need to flip the second half over. Right, so I've got 16x squared plus 8x all over,
6x minus 3.
good, 6x minus 3. Okay.
Take 4x off the
Okay, now I need to, wait, what?
top.
Lucas gives up. Okay. So, let's see, which things can I factor easily?
You can factor the first part to 2x plus 1, 2x minus 1.
Okay, the first bit, right? Left top is a difference of squares. So I get 2x plus 1 and 2x minus 1 out of that. Okay, how about the bottom? What do I got there?
3 times 3 times 2 times x times y.
Okay, there's a 3, a 2, an x, and a y. Right, that's left bottom. Okay, how about this thing? The right bottom. What can I factor out of 6x minus 3? I can pull a 3. So I've got another 3, and then there's what else?
2x minus 1.
2x minus 1. Very nice, guys. Okay. Oh, there's a onesie. I see that. Cool. All right. What else have I got up there? You can pull an 8x, right? That's a 2 times 2 times 2 times x. I'm okay if you don't do all of these steps all at once, by the way. If you want to kind of leave the numbers till the end, that's okay. All right, what am I left with after I factor out an 8x there?
2x plus 1.
Ah, cool. 2x plus 1. Okay. Now what cancels? I'm going to use a different color for onesies on this one. Oops, that's the same color.
You have a 2 on the top and a 2 on the bottom.
Okay, so maybe there's a onesie.
And X.
So that'll cancel those guys. So then there's an x.
Yep. And then there's a 2x minus 1.
Then there's a 2x minus 1. Okay. Anything else?
Yeah, that's better.
That looks like it to me. Okay, so what am I left with?
2x plus 1 squared
Okay.
with the 4.
Yeah, I should probably put the numbers first. That's just convention, though. Don't sweat it if you put them back. If you put them backwards, I would personally put 4, right? Times then there's 2x plus 1
Squared.
squared because there's 2 of them. Okay, and on the bottom
27 y.
I've got a 27. Cool. Questions about where anything came from there? No? Okay, cool. This is pretty much how multiplication and division go. Are these different than the exercises you were doing in 9.1? Not really. These are pretty much the reduced things, except you have to remember how you multiply fractions, right? The thing I want you to take from this, like the big, huge thing here, is just, although these are terrifying, right, and although there's this function thing happening in the back of your head, these are still just fractions. When we go to adding them, we're going to treat them just like fractions. We're just going to find a common bottom and add. Okay? Same thing we always do. Cool? Alright, that's what I want you to take out of this. So